Hi, sixth graders. Today's notes are going to be on adding and subtracting fractions with like denominators. So I'm just going to say add and subtract fractions. And underneath that in parentheses, I'm going to say like denominators. All right, so let's look at some examples. Let's just jump right in. So example number 1. If I am asked to add two fractions, so let's say 3/8 plus 2/8. When I'm adding fractions, I want to make sure that my denominator is the same. And of course, today we're talking about adding fractions that already have the same denominator. Later in the week, we'll talk about what happens when the denominators are not the same. But for our purposes today, when we're adding eighths plus eighths, of course, our answer is still going to be in eighths. So our denominator stays the same when we add fractions. The only thing we have to add together is the top number. So I'm just going to go ahead and do 3 plus 2, 3, 4, 5. And it's as simple as the final answer being 5/8. So denominator does not change, just add the top number. So let's look at another example. So let's do maybe an example beside of this one. So example number 2, let's say we've got 4/9 and we're going to add 2/9 to that. So again, denominators are the same. I'm going to keep my denominator, so that is 9, and then I just add the top numbers. So 4 plus 2 is 6. Now, you have to be careful when you get your answer, because if we look back at our answer over here, 5/8 cannot be simplified. But think about what we learned last week as far as simplifying fractions. There is no number for this answer that can divide both 5 and 8. However, there is a number that will divide both 9 and 6. And so what I'm going to do is I'm going to come down here on a different line, and I'm going to say, okay, 6/9, but that can be simplified. And the number that will actually divide 6 and 9 is 3. Now, if you need to go over and write out the factors and say, you know, the factors of 1 and 6 and 2 and 3, and the factors of 9 are 1 and 9 and 3 times 3, of course you can do that. But notice that they have 3 in common, and so 3 is the number I'm going to be dividing by. So 6 divided by 3 gives me 2, and 9 divided by 3 gives me 3. So my actual final answer here is going to be 2/3. So again, we're adding fractions, denominator stays the same, numerators get added, and if you can, simplify. All right, let's look at what happens when we have some mixed numbers. So example number 3, and we're actually going to do 2 of these as well, so it might be helpful to just go ahead and split your paper all the way down the middle. So we can fit 2 examples on either side. So example number 3, we're going to try 1 5/7 plus 2 1/7. So notice we have mixed numbers here. We have whole numbers, and then we have fractions. And so the only difference here is going to be that we are going to think about our whole numbers together, and we're going to think about the fractions together. So whole numbers are going to go together. We're going to add those, and then fractions are going to go together, and we're going to add those. So let's do this step at a time. Add the whole numbers. 1 plus 2 is 3, so that makes 3 wholes. And then we're going to add the fractions. So 5/7 plus 1/7. Again, denominators are the same, so the denominator stays the same. It's going to remain sevenths. And then we add the numbers on top. So 5 plus 1 gives me 6. Ask yourself, can this fraction be simplified? 6 divided by 7, or is there a number that will divide both 6 and 7? And no, we know that the factors, of course, for 6 were 1, 2, 3, and 6. 7 only has factors of 1 in itself. And actually, there's a trick here. If these two numbers are only 1 apart, so if it's 6, 7, if they're right next to each other, it is automatically simple. So that is our final answer. That does not need to be simplified. Let's do one where we might have to simplify. So example number 4, let's try whole number 10, 1/6, 10 and 1/6, plus 7 and 1/6. All right, let's try this one. So again, we've got whole numbers and fractions, so we're going to think about the whole numbers first. Then we're going to think about the fractions, add those together, and then simplify if we can. So whole numbers, 10 plus 7 is 17. And 1/6 plus 1/6, they're both 6, so 6 is going to stay on the bottom. And we add the top numbers, so 1 plus 1 gives me 2. Now, can this fraction be simplified? It can. The factors of 2 are 1 and 2. The factors of 6, of course, we already wrote up here, are 1, 2, 3, and 6. And so they both have a 2 in common. And you may be able to look at this fraction and just say to yourself, hey, both of those numbers will divide by 2. So we're going to simplify it now. When we simplify 2 divided by 2, we get 1. And 6 divided by 2, we get 3. But your answer is not just 1/3, right? We still had 17 out in front. So we want to make sure we bring down the 17 as well. So 17 and 1/3. So that's adding, right? Adding fractions works just like normal. Add the numerator, keep the denominator. If you have whole numbers, you have to add them as well. And of course, simplify in the end if you can. If you need to pause the video and maybe think about that a little while or catch up on writing the notes, go ahead and pause the video now before we deal with subtraction. So I'm going to separate my page again, and we're going to do some subtraction examples. So example number 5. Let's try 5/9 minus 3/9. So we've got 5/9 minus 3/9. Again, denominators are the same, so that's good. So just like addition, I'm going to keep my denominator. If the bottom number is 9, it's going to remain 9. But now, of course, instead of adding, we are going to subtract the top numbers. So we're still just dealing with the top. 5 minus 3 gives me 2. And of course, like always, I ask myself, can this simplify? And no, 2 only has factors of 2 and 1, and 9 will not divide by 2. So that is as simple as that example goes. Let's try one where we might have to simplify. So example number 6, let's try 6/10 minus 1/10. Same rules apply. Both of these are tenths, so I will keep the denominator. And 6 minus 1 on the top gives me 5. Now, I ask myself, is this simplified? And 5/10, of course, is not. 5 and 10 are both divisible by 5. And if you need to, you can write the factors out. So we can divide both of those by 5. And actually, 5 is half of 10, right? So it makes sense that 5 divided by 5 would give me 1. And 10 divided by 5 would give me 2. So the actual answer here is 1/2. All right, we've got last 2 examples. You have to squeeze them in here on the bottom. So separate your page. Move my paper up to the very last section. So let's look at a couple of word problems. You are going to see some word problems on your practice. So this is going to be example number 7 and example number 8. And of course, we're going to write down some word problems. So let's say that Joe had 12 2/3 cookies. I guess he ate part of one. Also, Alex had 4 1/3 cookies. Maybe they broke off. Maybe somebody took a bite out of them. I don't know. How many cookies all together? So we want to know how many do they have in total, how many did they have together. And so we've got 12 2/3. So think about it a second. Are we going to add or subtract here? So we're going to have to choose between addition and subtraction. So if we want to know all together, of course, one had 12 2/3. The next one had 4 1/3. And of course, if we want together, that is an addition problem. So you should choose addition. And so after we choose addition, now all that's left is to add them together, just like we have been doing up here. So 12 plus 4 gives me 12, 13, 14, 15. 16, so my whole number is going to be 16. And if I add these two fractions together, we end up with 3/3. Now, that's by adding the top 2 plus 1, and then the bottom remains the same. Now, what is 3/3 the same thing as? Well, 3/3 actually becomes 1, right? A number over itself is 1. So if I have 16 and then 1 more, this actually becomes the answer, 17. So 17 cookies in all is what they end up. That's taking the 2/3 of the one part that Joe has and adding another third to it makes another whole. So if you simplify in the end, and of course you could have shown that by dividing by 3 on both sides, but of course that gives you 1/1, and this whole thing just becomes 1. So 17 is the final answer here. So last word problem, last part of the notes, we're going to say that we, if I can spell, we have a string which is 9 7/8 feet long. I cut off 1 3/8 feet of the string. How much is left? All right, so we want to know how much is left. So we are going to have to decide between addition and subtraction. Of course, we have 9 7/8 and 1 3/8. Do you think we're going to add these together or subtract them? Well, if I cut off a piece, that's taking it away, correct? So I'm going to subtract. So I'm going to subtract again. I've got my whole numbers, subtract them. 9 minus 1 gives me a whole number of 8. And I've got fractions. So 7/8 minus 3/8, they're both 8s. So I'm going to keep my denominator. 7 minus 3 gives me 4. The last question I always have to ask is this fraction simplified? And of course it's not. You can divide 4 and 8 both by 4 if you needed to write out a little list to find. You could actually divide them by 2 and then 2 again as well. But the quickest way is to divide by 4. And so 4 divided by 4 is 1. 8 divided by 4 is 2. And of course make sure you bring the whole number with it. So the final answer is 8 1/2. All right. So make sure you have all of those examples written down, and you may practice this process with the quizzes, and then there's an IXL, and then we'll take a quiz on this. So if you have any questions, make sure you email me.